So firstly, thank you for joining my today's session. I'm Mitsufumi Kikyotani. I'm going to be talking about tucking in the legacy with Temporal. Before getting into the details, I want to give you some overview of my talk today. I'm going to talk about three things today. First thing is how we improve the productivity with Temporal. Second one is how we improve the system stability with Temporal. And also last thing is how we transitioned out of legacy with Temporal. What we achieved are three things also, three metrics here. First thing is we improved the development speed 6 times faster. We made 350 hours in a year to the near zero. And we also transitioned from legacy in 3 weeks. I have to admit, these numbers are marketing bullshit. These numbers are not important. You will see why in the later, but the most important thing is we couldn't achieve any of them without Temporal. All right, I think introduction is enough. Let's get into the details. Let me start with what is Airwallex first, full year. Airwallex is a unicorn startup originally founded in Australia, Melbourne. The founders find the inefficiencies, the global business in the financial domain, such as banking, transfer money, or exchange the currencies. That's why they started implementing the global financial platform and offering the global account. You can hold over 150 countries for 60 plus currencies in the single platform for business. Also, we issued the Visa Airwallex card to help the business to spend the expenses out of their account easily. Now, because we provide the financial services to the businesses, we also need to integrate those data into their accounting system, such as bank transactions, expense data, or bill data. We need to send all of them to their accounting system for their audit purpose. Today's talk, I want to talk about this integration because it covers the essential business requirements and how the Temporal solves that. Also, it's relatively easier to understand in the limited 30 minutes. And I'm going to use the expense for the next few slides, in the remaining following slides. So now, when we first implemented the expense integration with the accounting system, we implemented without Temporal. And we came up with this beautiful architecture at the initial stage. We already implemented the expense service on the top left block, which is responsible for the entity lifecycle of the expense. It's writing the data of the expense events such as create expense, submit expense, approve expense. And there is a CDC, that's change data capture, connected to the Kafka. And the Kafka is consumed by the sync service, which is the purple colored box in the middle, which is responsible for the integration to the accounting system. Because of the nature of the third-party system integration, the integration can be broken by any reason. Sometimes the customer uses invalid accounting data attached to the expense, and that expense is rejected by the accounting system. Or it could be because the third-party system is broken and down for a while. Or it could be because there's an API rate limiting on the third-party system. To handle those kind of errors, we wanted to add the non-blocking retry, which is the normal requirements as you have. Like we don't want to block one customer's failing event, blocking the other customer's genuine event. So we came to the traditional approach of this Kafka, adding the retry topics here and the DL topic. Now, sync service can consume the event, and they also do the keeping retry up to the number of the Kafka retry topics. And eventually, it can publish into the DLT and moving on with other events. It's traditional, right? If it helps the system to be stable, but it doesn't end the story. If it doesn't end the story, I would talk about this as a success story in the Kafka Replay conference. But essentially, we found more things as the product development is going. Like the expense was actually composed by multiple objects, such as receipts and notes, and the receipts can be attached multiple receipts to one expense. So It means essentially we need to make the multiple API calls to make the sync integration successful. And every individual API call can be broken by the same reason I just mentioned. We also wanted to apply the same retry mechanism for every individual API calls. That's why we came to this chaos. Like after the expense sync successful, we also added the receipt sync and node sync Kafka topics with retry and the DLT. And now the sync service can sync the nodes and receipts in the reliable way for the integration to the accounting system. Well, I don't know what's your reaction to looking at this architecture, but my first reaction to this architecture when I joined the Airwallex was like this. I got a headache because the integration requirement was really simple, just sending the expense to the accounting system, but the architecture itself is really, really messy and complex. Also, it's not that it looks ugly or intuitively looks complex, but actually there's a fundamental problems behind this architecture. And the first one is the poor code readability. There are over 45 Kotlin files for this integration, and over there are 1,000 or 2,000 lines of code. And the majority of the code is not for the business logic. It's for the handling the errors and making system reliable and stable. And there is also another issue because there is an expense sync Kafka consumer, receipt sync Kafka consumer, and the node sync Kafka consumer, which means there are multiple entry points for this pipeline, and there's no way to understand that this is an entire process straightforwardly, right? And next problem with that architecture was the fragile integration and the flood overrides. In the year of 2022, we released expense integration for the first time, and we had 350 alerts in a year. It's like every day, one alert, advent calendar for you. So those alerts, those 350 alerts, mainly because of sometimes the customer use the invalid data and it increases retries and it hits the rate limiting from the accounting system. Or it's sometimes because in the end of the financial period, the customer produces lots of the financial activities, which also hit to the API rate limiting or could be hitting the Kafka offset lag as well. And sometimes it's also the genuine bug our engineers introduced, but luckily it wasn't the majority of the reason. But the annoying thing here is those errors can be interconnected. Firstly, it's starting the error by the genuine bug, but it increases the retry as well, which also increases the probability of hitting the API rate limiting. And that's breaking the other genuine events failure as well. And in the result, of course, it comes with the Kafka offset lag as well. Because those errors can be interconnected, our engineers sometimes take a look on the log and make sure that integration is not broken, which is a waste of our engineers' time. Last problem, not least one, is the lack of the scalability for the future requirements. We could survive with this integration if that's the only single point of the system, but we actually had much more requirements for the incoming product development, such as we actually implement the reimbursement service and the bill service in 2023 and 2024, which also we need to integrate those data to the accounting system. And also we expanded the support of the accounting system to the 3 accounting system, Xero, QuickBooks, NetSuite. It's not something, I have to say, it's not something wrong with Kafka. This is something wrong with how we use them. I love Kafka, to be honest. But it's been said, there are already a lot of limitations with this current existing architecture. And to continue providing the more features in the roadmap, we need to find another solution. And that's why we came to Temporal. Before getting into the solution details, I want to cover what's the requirements that we have for this integration. First requirement was the resiliency. we want the application or system to handle the errors or failures smartly and make sure that it's a durable execution. And second one was a non-blocking retry. We don't want a single customer's failing event not blocking the other customer's event as well. Third one is idempotency. Expense can be successfully synced, but if there's any receipt or notes are unsuccessful, we want to roll back the expense from the out of accounting system. We want to make the pipeline transactional. I assume the audience here is already familiar with Temporal, but I will not talk about the details, but the beauty of the Temporal is that those key requirements are covered out of the box, such as activity retry or workflow history, event history, and also the workflow saga and workflow histories. Those features support those key three requirements out of the box. But there's one more thing, which is not always well documented in the technical document, which is the fact of the requirements of the uninterruption to the product roadmap. This is also common for the growing company with legacy, which is the legacy code. Generally speaking, it's doing well. Like 99% or 95%, it's doing what customers need. But certain corner cases, in our case, at the end of the financial period, we provided the legacy, the poor UX because of the data limitations. Also, in the product roadmap, there are a number of the feature requests or product requests, and that also promise the business growth or revenue growth. In this kind of situation, the business is harder to prioritize the refactoring of the legacy code instead of investing the engineer's time into the product development. So the final question or final requirements we had for Temporal was, can we make it refactoring the existing legacy code without disrupting the product roadmap? And the huge win of the Temporal is that Temporal can answer with this question with absolutely yes. So I'm going to tell you why. This is the logical flow of our pipeline. It consumes the expense event, process it, and integrate it with the accounting system, and then handle the errors if there is any required. I would categorize those four blocks into the business logic and infrastructure logic. Business logic is something satisfying your product requirements. And the infrastructure logic is something satisfying the non-functional requirements, such as stability or scalability. And the huge win of the Temporal is that you can focus on the business logic and wrap your business logic into the activity and put them into the workflow implementation and execute them. Because you don't need to, it's not necessary to change your business logic itself, it was incredibly easy for us to move out from the legacy into the new architecture. So now let's get into the exciting part, how we improve the legacy system with Temporal. This is left-hand side is the legacy architecture I already displayed in the previous slide, which is using the Kafka retry topics and the DLT to make the integration stable. With Temporal, we successfully redesigned the architecture to the right-hand side. Just look at that. All the complexity of the infrastructure is removed by Temporal, and now sync service only talk to Temporal to enjoy the durable execution provided by Temporal out of the box. Also, not only the architecture, but the code is also looks very simple. This is kind of simplified code from the actual production code, but as you can see, the 40 files Kotlins expressed into the single file, and the engineers can understand easily, straightforward, because the previous architecture, there's 3 entry points of the integration, expense, notes, and the receipts, but now single workflow implementation file is showing what we do in this pipeline. I also want to talk about this code a bit more details with talking about the challenges we solved with using Temporal. First challenge we solved was API rate limiting from accounting system. Because that's an external system, we don't have a control for those system integration. And in the initial architecture, the limitation was the number of the retries are limited by the number of the topics, retry topics. And that is limited by the infrastructure, so we cannot increase the number of retries on demand without blocking the other customer's event. But with Temporal, it was really easy to using the workflow.strip, and we just implement this kind of code, wrapping function. This is wrapping our activity execution. In this code, we execute the activity in this block, and if there is any exceptions captured in the try-catch section, and that the activity exception is caused by the API rate limiting, we just need to calculate the next interval and do the workflow.strip. Then we can keep processing the other customer's event, but we can also come back after the rate limit is expired. Also, another challenge we solved with Temporal was the rollback. In the initial architecture, this was the logical flow of how we process the events. Firstly, we sync expense, and if it's successful, moving on to the receipt and notes. And we want to make that pipeline transactional. That's why we added the rollback system, rollback logic in the DLT consumer, which is a legacy code though. The annoying thing here is the rollback was not easy and it's complex because in this choreographic architecture, not DLT consumer does not know if it should roll back the receipt as well. Could be receipt is also unsuccessful and the receipt sync already rolled back the expense as well. Or maybe not sync is successful and the receipt is failing. Maybe they need to, receipt DLT consumer needs to roll back everything as well. But there are a lot of the patterns and it's pretty complex to implement all the possible patterns in the rollback logic. But with Temporal, we can easily implement with using the Saga. In this simplified code, we execute the activity to sync expense, also handling the throttling, and we receive the response from the third-party system of the unique ID of the expense object in the system, and we just add the rollback activity into the compensation Saga. We can also move on into the other subsequent process of the receipt sync and note sync. And if there's any exceptions, we can just execute the rollback compensation here, and it's going to be rolled back easily. This also making the sync pipeline really straightforward and helps the engineers to understand and also increasing the productivity for engineers to add more feature or refactor or maintain this code. Last one, but not least one, is the testing as well. With initial architecture, we had a lot of pain points with the testing because the integration with Kafka is always asynchronous. And when we run the integration test or BDD testing or end-to-end testing, we need to make sure all the infrastructure is set up correctly. All the infrastructure includes the retry topics, the main topic, and the DLT topic. And those tests can be easily flaky without writing the code carefully because it's asynchronous. The event can be processed concurrently, and we may need to test really carefully as well. But with Temporal, it was really easy for us to write the code because we can just use the JUnit Temporal in memory Temporal. And also, if you really need that, you can also use the Temporal write container. Also, the Temporal has a cool feature of the replay testing. As the product grows, you may need to add more activity, more features onto your workflow implementation. But with Temporal, you may need to test the backward compatibility with your product from time to time. With Temporal, you can also easily to make sure backward compatibility is using replay testing. You just need to the replay test only succeed only when your newest workflow definition is backward compatible to the previous workflow definitions from the deterministic point of view. We usually put all the history of the workflow, all the previous definitions of the workflow to the repository, and the CI/CD will handle that to make sure your workflow is backward compatible, and which increase our confidence to release the feature to the production. All right, so it's coming to the end of the session now. I'm going to recap what we achieved with Temporal here. First thing, we achieved the productivity improvement, which is that we spent 6 months and 3 backend engineers to implement the first accounting system integration. But we only needed 2 months and 2.5 backend engineers to implement another accounting provider integration. Also, we made the 350 alerts into the near zero by using the Temporal's activity retry and the retry policy, and also using the workflow.sleep of the non-blocking weight as well. And we transitioned from that legacy system, which produces many alerts, in 3 weeks, including development, testing, and release to the production, and feature flagging to make sure the gradual release. It was all 3 weeks. It happened in all 3 weeks. This is all about my session today. But I have to tell you something really important before closing this session, which is the fact we are hiring. So if you are interested, or if you have some fun or enjoy today's session, please go to the airwallex.com/careers, and we are hiring globally. All right, thank you for listening today.